This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Thank you everyone for joining again. Toby has also joined, I can see that. So without any delay, I'll hand it over to Toby. And maybe we will start with a few questions that you might have at this stage. What do you think, Toby? I'm not receiving a response from Toby yet. So let's wait for him to join in.
So we're continuing with the Excel.
Yes, that's correct.
Okay.
Hi, Jyoti.
Yeah, hi, Toby. So I was saying that you want to start the hands-on straight away, or you think this will be a right time to first take a few questions and then progress with?
Happy to take questions, and then we'll go through some Excel and GIS.
Yeah, and in the meanwhile, probably a few other students will log in, so we can use the waiting time. So anyone has any questions at this stage?
I might have one. This is in like a general, very simple question in terms of the network plan. I don't know whether you're allowed to like answer this, but like I was curious in terms of like how long does it take to create like a network plan for like a normal Coles outlet?
It takes a while. Those 9 steps that I ran through can take a matter of months, particularly getting stakeholders across it. But it's something that's a continuous document. It's constantly refined. It's constantly changing, and it's constantly having to be socialized among stakeholders. So it's hard to put a specific time frame. Like you'll see the scorecard approach that we're going to do can be done pretty quickly. But it's a matter of constantly refining it, so and constantly updating it to reflect changes. So we've had to do a lot of work that factors in the impact of the pandemic on population. So that takes a fair bit of time, but we're largely updating the existing network plan. So it's not something you do once and then leave it. It's constantly refined. So for that reason, it's hard to sort of give an exact time frame on how long it takes to create. But I would think of it more as a continuous task rather than a discrete one.
All right, awesome, thanks.
So if anyone else has any question, then please go ahead, and otherwise we will just start with the hands-on session because I think it will take some time.
Yeah, hopefully not too long. I'm hitting the wall a bit. It's been a long week, but I will analyze data and map through the pain barrier. I just want to emphasize with what I'm doing that might seem a bit challenging and daunting, but it's nothing too difficult. It's really some Excel, basic Excel, and some basic GIS. And I would see it as a good opportunity to challenge yourselves. After all, you're master's students at the best university in the country and focusing on one of the biggest industries. So it's good to really challenge yourself with these techniques and learn at university first, so that you can pick it up quicker on the job. So I'll pick up where I left off and emphasise the process that has been taken. I'll just share my screen. So what we talked about was getting the census data, and I'm using 2011 census data here, so don't be too concerned about that. It's a bit older, but it's just to serve an example. We know what the data is from the metadata that tells us what each of the variables are, and what each of the tables in the Excel files are. So that's the summary of what we're looking at when we go to the broader census folder, which is here. So all of these tables, and then what I've done once I have them, and I've opened up the first one, table number 1, is I've chosen the suitable variable that I want, that supports me with my data analysis, and I've put that into a raw data file with a number of other suitable variables. So I've taken the SA2 as the primary column, the geography, and then I've added a number of relevant variables to get a raw data set with all the relevant files that we need. So when I pull that up in my scorecard workbook, you can see primary column, and then I've added a few variables, the CEFA variable that we talked about. And what I've done is I've just copied and pasted these because they come from the ABS file, and the region IDs in column A are in order from 2010, 11, 001 all the way through to they're going up in order from lowest to highest. You can just straight copy, as long as the structure of the table doesn't change. The number to the region ID should always correspond, no matter what table number you're looking at, what file number you're looking at. So you can just copy and paste like I've done. So I've put in the variables, and keeping in mind, this is for a hypothetical retailer that is selling products for newborn babies and parents with newborn babies. I've put in, like Baby Bunting, I've put in total population in each SA2 with 0 to 14 people 0 to 14 years of age. I've put in the number of people in each SA2 who are married. I've put in a variable which is in ABS data of which people had a different usual address 1 year ago. And the reason I have done that is because I've made a hypothesis that if you have a different usual address to 1 year ago, you've just moved house. Therefore, you're more likely to have potentially moved house to upsize, or you want to have a bigger house or change house to support a family. Now, I understand that's fairly loose reasoning, but what we can do is we can, because that may not seem as certain, we can downweight that when we score it, so we don't have that influencing things too much, because there's other reasons you may have a different address to 2 years ago, so that's fine, or 1 year ago, that's fine. There was a variable we talked about in the lecture about childcare, unpaid childcare, and that column heading is persons total care for own child care, and that's the number of people who meet that category if they give unpaid childcare for their own child. So the number of people who do that, again, I thought that was going to be favourable towards households, finding the households in areas that have a high proportion of younger families that are going to appeal to the product that we're talking about. And then the final one, again, more of an abstract one, but I'm putting my analyst cap on and testing a hypothesis, which is the number of motor vehicles per dwelling. If you've only got 1 or 2, you're less likely to have older children, and you're more likely to either be looking to start a family because you've got only you and your husband or you and your wife. That again is something that I think lends itself to households with only 2 people, 2 older people, and if they're 2 older people in a household, they may be looking to start a family and they may not have older children. So that is the raw data. All of that, except the CIFA, which is a separate data set that you can Google, is from the ABS. And of course, importantly, we've got the total number of people, which would never, none of these variables would ever exceed the total number of people. So this is saying 1,965 people out of 8,345 are between 0 and 14. 3,522 out of 8,345 in this SA2 are married. So that's the raw data set that we have. And these are the variables that we're saying are relevant to our retailer. And when we rank them, we'll help understand the locations that maximise the chance of our retailer succeeding. So that's the raw data set. And like I said, that was done from copying and pasting from the ABS data sets that are publicly available and can be accessed via those data packs websites. The next step is to take this from being a raw number and to putting it into a ratio, because when you're working with data, raw numbers are good, but we want to understand the proportion, because what we're saying here, and this is the prime example, the difference between the first SA2 and the second SA2, for example, you've got roughly the same number of people who give that childcare to their own child. The SA2 002 has slightly more in a raw number sense than SA2 001, but SA2 002 has 12,000 people and SA2 001 has 8,000 people. So as a proportion, 1,600 out of 8,300 is a much higher proportion than 1,700 out of 1,200. So there is a much higher concentration of people who give childcare in this SA2 than there is in the bigger SA2. So that's something you can only ascertain by getting a percentage. So what we're going to do is we're going to take the raw data, and I've somewhat already prepared it. So you just copy and paste it. Well, actually, I don't need to copy and paste it across. What I need to do is use a formula where we're going to go equals, and in the data column, the first one we're looking at is 0 to 14. So we want what proportion is that number, so that cell there, divided by the total population. So we'll go here, and that's total P, total persons population, divided by that. And that's just a basic calculation to get a percentage. So what is 1,965 as a percentage of 8,345? It's 24%. That's great. Now, we want to do that in every single cell in this table for every single SA2 and every single variable. Now, that's very straightforward because it's Excel. It's very user-friendly, and we just drag. But when you're dragging, it just drags the next column across. So data D2, which is here, when I drag that across, the next one will be data E2. So it'll do the same thing, but you need to make sure the population remains the same, because you want this cell here, each of these cells as a percentage of that. So that needs to stay the same. So just a basic Excel trick is you just put a $ there to lock that cell. So this denominator, C2, the total population, will stay the same, while the numerator will drag across to E, F, G, H in the other cell. So it'll be what is the value in E2 as a percentage of that cell there. And when you put the $ in front of the column, it stops it from changing columns. So there we go. So that's 42% married. What's that telling us? 3522 divided by 8345. And as you can see here, D2, C2, E2, C2. It stayed the same. That's good. That's what we want. And then once you've done that in the top row, you can just double click and hey presto, it's done it for all of them. Now, it's important in this situation just to do a bit of data cleaning, and some of them are going to have errors just because it's never perfect. We'll just look at the columns, and if there's an NA, that means there's an error. So we'll unselect all, select the errors, and we've just got to be ruthless with errors sometime and say, I don't want you causing me problems, so we're just going to get rid of you. So that gives us a proportion. And like I said, the example we gave in the top one here was the childcare one. So while in SA2002, the number of people, the raw number of people were higher in terms of people who give childcare, as a percentage of the total population in that SA2, it's 15, whereas the even though the raw number was smaller in SA2001, it's a higher percentage, and that's good. Now we've got a population adjusted ratio and proportion that helps us inform the scoring that we're about to do. So this is a minor manipulation of the data to get a proportion of the variables relative to the population in each SA2. And these are all the key variables that we're analysing. So the scorecard approach, all we've done here is just copied all of these variables and then pasted them in here, just a straight paste. And sometimes when you paste, I've just copied the formula. So if you press Control-C, it's going to copy the formula. Instead of pasting the formula, you can just paste the values. So instead of it pasting, if you look in D2 of the ratio tab, that's the formula, but it's coming up with 24%. We've just pasted the value, and then there it is. Instead of the formula, it's just the straight value. And sometimes that's a bit easier to work with if you're filtering the columns and the likes. So we've just pasted all of that in here. Now, what I've done, and I've hidden some of the columns because I did prepare this a bit earlier, is we need to then apply a score to each of these variables. The scoring is what starts to segment the variables and rank them based on their suitability and attractiveness. So if there is a high population, we want it to have a high score. And if the proportion of persons in that SA2 who are between 0 to 14 is high, we want it to have a high score so that they filter to the top. The ones that meet all of the right criteria filter to the top, and the ones that don't go to the bottom. So we can clearly distinguish which ones are good and which ones are bad. Before I launch into this part, I just want to check because I'm on a bit of a roll and conscious that I can talk a lot without stopping and checking. Is everyone okay? I'm conscious I'm going quickly, but are there any questions at this stage based on what we've done so far?
We are good, Toby. We have
Right.
some thumbs up, yeah.
So how do we score it? Well, I'll unhide these columns so you can see, but what I have done, as I'll get rid of that for now, we've copied each of these, and we've just added a similar corresponding column for each of the variables that we're analysing, and I'll delete CIFAR because we're not using it. It's a bit deceiving. We're not using it, so that's fine. We've got population, 0 to 14, married, different usual address, people who give childcare to their own child, unpaid, and also the number of motor vehicles per dwelling, people who have 1 or 2 per dwelling. We then need to create a corresponding column for each of those. And what I've just done is a basic, what's called a concatenation, where you add, I've just added the word score, but you could do that manually. All I've done there is gone copy, paste, and then you just add score. I've done that dynamically using what's called a concatenation, but that's essentially all I've done. Just differentiated it, same column, but to just the score component. And then in a separate tab, what I've done is I've hidden the columns, but I've pulled together just a table. And what I want to do is just quickly analyze in that column. I'll delete these. So for the total persons, I want to know what the minimum number is. So we use a very simple formula, which is min, and then everything in that column, what's the minimum? 36 is the lowest value that exists in this column here. And if we just have the filter, it's always good just to check that the formula is doing what you want. 36 is the lowest number. That's great. Now what I'm going to do is I'm going to break it into quarters. So in order to do that, you use a basic function called the quartile function, and it asks you what's the array, what's the column, what's the data you want to get the quartile of, and we want to get it from here. And then which quartile? 1, 2, 3, or 4, and we want quartile 1, and I could either type in 1, or just to be dynamic, I'm just going to put it on that cell which has a 1 in it. So it's the same as just typing in 1. And that then tells me the minimum number is 36, and then 25, the first 25% of the data, the upper limit of that is 7,000. And then because I did this dynamically, quartile, all of that data in column B, and then what quartile. And you can always remember that when you're looking at a formula, quartile, what's the array, and then which quartile. You can always click on that for a bit of help. Excel is very good and it's very user friendly. So when you click on that, it will tell you what the function is and what it's doing. Because I've used a dynamic cell reference, I can just drag it down and it's going to go same column, BB, and then A4, which is quartile 2, and then quartile 3. So 50% of the data is between 36 and 11,474.5. And then the next quartile, Q3, 25% is between that number and that number. And then everything above that takes us to the max, which is then the extent of the data. So what we do then is we make an assessment as analysts. So if the population is between 36 and 7,139, I want to give it a score of 1 because it's low. We want that those SA2s with that population size to be punished because they're small. So we're only going to give them a score of 1. Anything between 7,000 and 11,400 is going to get a 2. Anything between 11,400 and 17,000 gets a 3. And then what we're saying here is that anything above that number gets a 4. How we then use this scoring system to flow through to the scorecard is we use a formula called a VLOOKUP, which is a pretty common and popular one. And we're saying, all right, what's the lookup value? We want to look up that value, because it's the population score. Look up that value within this, my bad. Look up that value, first thing, then comma, in this array. So that's the score. That's the population number. That's the score. And you want to make sure this is locked. So you need to do $ signs on either side so that whenever you drag this down, which we're going to have to do for every column every row in the scorecard, that array that we've just defined remains constant. And then the column index number says, what do you want to return? It's that second column. So the table array is just B2 from there to C5, and there's 2 columns and 4 rows. And we say we want to return the second column in that array because there's only 2. And then we close the bracket. So this is saying, hey, Excel, look up that score, tell us which bracket it falls into. And we know it's 8,000, so it falls between, if it's between 7,000 and 11,000, and it gets a score of 2. And then once it's figured out where it fits in, it returns the score for the relevant bracket that it falls into, and we know it's a 2. So that's how we get a 2. And then we just double click. You can see here that it's looking up that value now in that same table array and the lookups of the score, and it returns the relevant number. So this one here has a higher population, 12,000. It's above that Q2 limit, so it's between there and there, therefore it gets a 3. So we've just scored every population variable. We'll now quickly do the same thing for 0 to 14 and people married. So we're looking at that. In that array, F4 does the same thing as the dollar signs, lockdown, comma, return value number 2, close bracket, boom. Click, and then the final one, same thing. Person's married, you want to look up that value, tell us where it fits in this table that we've created. So we're saying that if you're between 0 to 14 and you've only got, anywhere between 0 to 12%, you're only going to get a 1. The higher the proportion of individuals in the SA2 who are between 0 to 14, the higher score you get. And then we're saying here, the higher the proportion of married persons, the higher score you get. And then I've hidden it here, but prepared earlier all the other ones, same process. Sorry. So I've done this for all the other ones, and once you've done it and it's dynamic, you can change the score. So if we want to say that married is a really good indicator, we can really say, all right, 0 if you're 0% and 26 because you're in the lower quartile of the data. But if you're married, we're going to give you a 5. So you can see now scorecard in the married column. Now all of a sudden, some of them have 5, some of them have 0s, just because we've changed the scoring. So you can mix and match it as you please. I've just undone that for the sake of this. I've also just done a check just to make sure that we have an even number of 1s, 2s, and 3s and 4s, and we should, because they're even quartiles. Quartiles 25%, 25%, 25%. So what I've done just as a check is I've said, hey, Excel, count if everything in this column here, count if that, what's the range? I want you to count everything in column H and tell me if it equals what's in there. It's hidden by the formula, but we know that C2 in this tab is 1. So it's saying, hey, Toby, you asked us to look at everything in this column here, column H, and tell us how many 1s there were, and the answer is 107. Drag it down. We've asked everything in that column. It's 2. And that's good because we've asked for quartiles, so there should be even 25%. There's all even numbers, and then 107 is 25% of 428. So that's good. That's just an example of what happens when you don't lock it down. So it's gone D2, what is 107 as a fraction of D6, and I just drag down, and then it drags them both down. We didn't want this one dragged down, so we want to lock D4 down with F4 or dollar signs around the numbers, and then it's done that. So it's taken that down, this one down, but that one stays there. So we've scored the variables, we've created columns, and then we've VLOOKed up the value in the raw data that's now a ratio. We've looked it up in our scoring system, and then we've applied a score. So we've got the scores, and now what we should do, in my view, is we should sum it up. So a simple sum formula tells us the total score of each variable, and there's 1, 2, 3, 4, 5, 6 variables, and they've all got a maximum score of 4. So that's 24 as the total possible score. That's jumping ahead a step, so I'll just put that to one side. Now we've got those 428 SA2s, and that's all of Victoria and SA2s. They've been scored. What's worth doing now is just a quick data check. You know how I had in the network plan file 2 sort of generic things about sense checking and national checks. This is just an example of when you as a human and an analyst want to make sure the computer's doing what you want it to do. So I'm going to look at all of these scores. I've just copied all 428, and I've created a tab that has distribution. Now we want to look at the distribution of the data. So I'm going to paste the values, because if I pasted the formula, it's going to sum of everything to the left, and there's nothing to the left. So because it's a formula that I've just copied, we want to paste the values, because we're asking it just to paste specifically what the number is there, and it's done that. And then we're going to go, okay, remove the duplicates, because we just want to know the individual scores that exist, because it's not necessarily going to be 0 to 24, because some might have different scores. So we'll go to score, and then we'll just go home, highest to lowest. And then again, we want to know how many are a 24, how many have a perfect score, count if, how many have a very low score. So we go back to here and we go, hey, Excel, look at everything in column N, and then tell us how many 24s there are. 3. So 3 out of 428 have a perfect score. That's not bad, because you don't want everyone to have a perfect score. You really want to discriminate and segment the SA2s based on their suitability. So that's looking all right. And to me, that's looking okay. That quite a few in that 22 to 21 bracket, which is interesting, but we'll just figure out now what the proportion of those is. I'll just quickly make that a sum so we know what the total number is. It should be 428, and then the percentage. So ideally, this looks something like a natural distribution, and it's not clear whether it does or not. Best way to sort of tell is by pulling together a quick chart. If we go insert chart, that gives us a bit of an idea that there's very few that get 24, but it starts to drop off at either side. So we've got a couple of low number of really bad ones, fairly high number of poor ones, and then fairly large number that are just meh in the middle, average. But then we have quite a few to pick from in the 21 to 22 and 23 range, and very few perfect ones. So once we've figured out how many have gotten each score, we probably want to put them in buckets, because we don't want to have 20. We don't want to have there's 19 total scores. We want to then put these in buckets, and if you just bear with me, cool. We want to put these in buckets. So so we'll call anything that is 24, 23 or 22, which are the highest scores, very high. And we know that that from here is about 11% of the data. The next one, 21, 20 and 19, we'll call that high. So it's good, but it's not great. Next ones will go sort of medium. And then quite a few mediums. So that only corresponds to about 32. We'll probably put one more medium in, and then low, very low. So now we've assigned a bucket to each score, and that's when we come back to the scorecard. And like I said, because we've got 19 different scores, that can be messy. Now we've actually only got 1, 2, 3, 4, 5 different scores: very high, high, medium, low, and very low. So now what we want to do is we want to apply what we're calling a bucket to a score. And that's really done by this. You go same VLOOKUP, just like we did for the scores. We want to look up that number in this array. I'm going to miss one. I can fix that after. And we want to return the value in column 1. And in this case, the final thing, it's asking for the range lookup, and you have to give true or false. False means it's an exact. Uh-oh, that's the problem with live television. Sometimes it doesn't cooperate. Bear with me. Just change the order around, so let's see if that's a bit more cooperative. Scores lookup. Anything from there down. Won't include the top one. We want to return we've only done 2 columns, so we want to return the value in the second column, number 2, column index number 2, and then false exact. Right. So that's returned medium. So we'll just double check that, because sometimes the computer can do things we don't want it to do. 17 equals medium. Great. So that's locked down. So when I drag it down, it's going to keep the table array the same. And we've got a bucket for each. Some of them have a 0, and that's because I didn't assign a value to 6, which should be very low. Back here, there should be no zeros. Perfect. So now we have things that are high, low, medium, very high, and low. Great. So now all that's left to do is pull this into a GIS. Now, I understand that was a bit quick and I got the formula slightly wrong, but rectified it. Is there any questions at this stage? Because now we're going to go from Excel to GIS. But the important emphasis here is all I've done, well, done a bit, but fundamentally what I've done is I've now ranked every SA2 in Victoria based on its suitability for a baby and parent purchasing for their baby retailer, like Baby Bunting. I've chosen variables that are suitable and I've ranked them and now given every single SA2 in the state a score based on its suitability for that type of retail. If there's no questions, I will get to the GIS phase, and so I just made a mess. So we've got the scores. I'm going to copy, and I might copy it into a new workbook. And then I'm going to paste the values. Center it, that's fine. So now this is our table that's going to go into QGIS. I'll just save it as something generic. Baby score SA2. And sorry, you'll probably want to save that as a CSV because that's what GIS platforms like. So I've just saved that as a CSV. Now we open our good friend QGIS, and that's what we're going to produce. Don't save it. No. So first thing we'll do is open OpenStreetMap so we know what we're looking at, and then we'll head to Australia. Now, I know that in a previous lecture, you guys had some SA2s for Greater Melbourne, so I'll open that shapefile. So that looks good. So we've just done it for all of Victoria, but this is the area in question. And sorry, I don't like the look of that projection. So let me just open the other one. That looks a little bit better. Let's just run with it. So they're the SA2s in Greater Melbourne that we're going to analyse, and it's fine because we've just applied a score to every SA2 in the state. These will all be captured. So what I'm going to do now is I don't like it when they're both open at the same time. So let's close these. So I'm going to join on all of the data that we've just analysed. If we go to the, wherever I saved it, I think I saved it in lecture. Baby Store CSV, I'll just open it, I don't want to do that. The beauty of QGIS is that we can just have it open and I can just drag the CSV and drop it. Now it's in the browser, in the section. And now, because we have the benefit of the first column in the table that we've just created. This is the table we've just created with the proportions and all of the scores. The column here, the SA2 code, is the same in here as it is in the shapefile SA2 main code. So all we have to do is go to the shapefile and go, we'll double click. And we want to do a join, add the join. So we're going to join the baby store data. That whole table is what we're joining. And we're going to join it to the field we want to join is the region ID, because that's the SA2 column, that's the SA2 name. And the target field is what we want to join that to. And what you join it to has to be the same number, the same value as what's in the table that you're joining it from. So the SA2 main code, that SA2 number is the same as the region ID. And then we want to go join fields, and we're going to join the number of persons, all of these values. Total and bucket. So all of those columns from the baby store SA2 table that we just created are going to be joined to the Greater Melbourne table. And it's going to go, all right, we're going to find the region ID number, and then we're going to add all of those values to the same region ID number, or the SA2 main, in the Greater Melbourne shapefile. And it's going to do it for all of the relevant SA2s. So we go, okay, apply, okay. And now when I open this, you can see that all of this is now in the Greater Melbourne data table for the shapefile. So instead of there being 428, there's 294, but the Greater Melbourne SA2s are a subset of the Victorian SA2s. But now we've got data that we've analysed ourselves to inform each of the SA2s in the shapefile. We'll close that. We'll go to the symbology pane. And we're going to go, all right, let's categorize it. What do we want to categorize? We want to categorize the buckets because there's 5 of them. Classify. We don't want it in those colors. We want it in a nice graduated color, like red, that makes the good ones clearly stick out. Now it's doing it in alphabetical order. We want it to be in our own order, so we're going to have to drag it a bit. High, very high down the bottom, high second from the bottom, medium in the middle, all of the values can go at the bottom, low, very low, great. Shouldn't be zeros, but that's fine. We'll just exclude them. And we'll exclude all other values, and then we'll just have to do that again so it recalibrates. So low is going to have a low shade of red, very high is going to have a dark shade of red. That's just from symbology, categorize. The value we want to categorize is the bucket, and we know they were the bucket values we assigned. You do a nice red color, or a color that stands out as showing the higher the color, or the higher the value, the higher the number, the more obvious the color. We apply, okay, and then boom. Now we can see which areas of Greater Melbourne have a higher colour and are therefore more suitable for the retail operation that we are considering. Now that's a straight colour, so you can get a bit more creative with the colouring and edit the colour ramp and maybe make it a bit more transparent so that you can see through to where the areas are. I suspect something like 50% will probably do us. Maybe it doesn't like that. Either way, you can sort of toggle to see what are the areas. So I'm looking at this large SA2 here. That's Whittlesea. That's a growth area. There's a lot of residential population coming in here, and that's telling me that there's married couples who might be moving out with a younger family to that growth area, buying their first home. So this is just helping us, like a GIS does, to clearly see where the suitable areas are for us to potentially locate a store of this kind. Sorry, let's just pan a bit. So now that we've got that better visualization of where we want to go, I'm going to go back to that file where your lecture or tutorial was conducted, and then we can add the shopping centres. So if we just click on the shapefile, boom, now we've got the shopping centres. So all of a sudden we know where the suitable locations are, where the shopping centres are, and now it's up to us to do a bit of a closer investigation on the suitability. So if I select this shopping centre, for example, the local village at Carrum Downs, that's good to know. We can do some Googling on that shopping centre and understand, what the size of it's like and what the current competition or retailers are like. And you can also do things like, once you've got a clear indication of where the shopping centres are and where the suitable areas are. I'm looking at these because they're all very high SA2s for our suitability scoring. You can click on the Greater Melbourne SA2 layer. You can select 1, 2. If you press Shift, you can select several of these SA2s, and then you can export selected features. We'll call this trade area. Sorry, I didn't like that. We will call this I'll just save it on my desktop. Now we have a separate layer called trade area. If we close that, we can edit it and just edit. Make sure you click the pencil to edit, edit, and we'll edit, select them all with Shift, Edit, and merge selected features. This table comes up, and then we can see here, this is the new table we're creating, medium, high, very high, medium. We can see the scores we've given each of the variables, and we can also see the proportion of things like the population, the married people, the caregiving, what warrants them being given the bucket they're given or the score they're given. We're going to merge all of those, and now all of a sudden we have a trade area. Yes, I do. I'm going to save those changes. And what we can do is we can change the symbology of that, make sure that it's nice and see-through, but the outline is very clear. We'll do it in a nice fuchsia pink, and the outline of the stroke is high. Apply. So all of a sudden, it's not a good color, sorry. We'll do it in a nice dark blue. That's the trade area of suitable SA1s. If we unselect. That's our trade area. It's not liking me with the selection, but you can see how we've now distinguished the suitable trade area for the shopping centre, which is located within the SA2s that we have deemed to be most suitable for our retail use based on the ranking of the variables that are closely correlated with a successful retail offering. So that's how I would go about doing this from an analyst's perspective if I was starting from scratch. And you know, obviously one of the important things to look at is if there are existing stores in, and I've just chosen one shopping centre, there's, you know, a lot of suitable SA2s around here. So you'd want to have a look at, you know, the shopping centres and see, you know, which ones they are, do some Googling. Does a retailer like that already exist? What's around, and how big is the shopping centre? You know, other factors that support the success of a shopping centre, and do some Googling, some investigation. Once you know that they're the areas you should be looking in, and that's how we've demonstrated that this afternoon and this evening. And then, like I showed, if you wanted to create some maps to show, you know, the area that you'd expect your trade to come from, you can merge and select the relevant SA1s and SA2s. And once you've created that trade area and merged it, you can open the attribute table and see all of the scoring for that trade area now as a sum of the 5 that I just combined. Now I'm conscious that's a lot of information. You'll probably want to watch it again and put it on a slower tempo so my rambling makes a bit more sense. I've worked up a bit of a sweat because you've got me on a roll doing something I like. So I'll go upstairs and my housemates will ask what I was up to down here, but I'll just tell them I was mapping and teaching enthusiastic property students. But I hope that's helpful and interesting. Like I said, I'm no expert. I've been at Coles for a couple of years and still think I've got a lot to learn in terms of location and spatial analytics. But everything I've just done, I learned at uni, and I got bits and pieces of lectures like this. So I hope I've been helpful in showing you a start. But that's really all I got. I got a start, and my interest helped me to investigate more. So I hope that this has planted a seed, and hope there are some questions. And I'm on the Teams chat for your subjects. So if you want to follow me up on anything, just send me a message, and I'll happily respond and answer.
Thank you so much, Toby. I'm smiling from being happy about all the information you shared and how very well it connects with the lecture content that you had delivered. And also, we have been talking about some of the concepts in our earlier lectures. I think it all knits very well. And without me rambling too much, I think we still have 5 minutes. If anyone has any questions at this stage, please feel free to ask. And there are more opportunities, of course, to ask and connect with Toby. But I'll let the time be used by everyone else. Godwin is also here. Godwin may also have some questions. Godwin was earlier discussing with us the QGIS and will again talk in the next week.
Yeah, I've got a question. So that how do you incorporate like the different kind of stores into the map? For example, like if I'm researching like a bicycle shop or a store, then like obviously like I can find all the bicycle stores on Google Map, but like how do you indicate it in like QGIS? I mean, it's only have like shopping centers in QGIS at the moment.
Yeah, interesting.
Or do I just have to look at Google Map and then try to understand? Like,
I guess a few options. You could do a print screen of an area and then just sort of annotate which of these have a bicycle shop, or what you could do is you could get the shopping centres table, open attribute table, and what you can do is you can this table is just like an Excel file. You can just export, save this as a where is it? CSV file, and I'm just going to save it to my desktop as bike shops. And then what you do is you could, if we go desktop, bike shops CSV, you could then add a column. In the bike shops CSV, which just said so we want a new column, bike shop, and then yes, and then do it manually. Obviously not for all of them, but maybe just a subset, because we've got 203 shopping centres. You don't want to figure out every single one that has a bike shop or not. But if you do sort of yes and no, then what we can do is save that, go back to our good friend QGIS, whack the whack the bike shops CSV table in. Let's see, I probably should have named it something else. What I'll do is I'll just remove both. Throw the bike, remove it. We want to throw the updated and saved bike shops CSV in, and then we want to join it back to the shopping centres, because now we've got a new column to add. So join. We want to join the bike shop CSV that we've just added. We're going to join it. We need to find a column that's identical. Now, every column in this is identical to the column in shopping centres, except for the one we just added. So shopping centre ID is a number that's identical in both, so that's fine. And it's also unique, so that's fine. And then join field, all we want to add is the bike shop column. Apply, okay. And now what we can do is, because we've added to the shape file, open attribute table, we've added this column that just has a yes or a no, for whether it's got a bike shop in the shopping centre. We can now go to the symbology pane, and we can go categorize. The value we want to categorize is whether it's got a bike shop. Classify yes will be orange. Sorry, yes will be green. No will be orange. Apply. Okay. And boom.
Yep. Thank you. That's
There's also another way of doing this.
very interesting.
Yes. So if you want, you could also just use your attribute table and create a new field in the attribute table. And then in the new field, then you can just also populate it. So the new field is also just a new column, as you would Toby showed in the Excel. But instead of exporting the data to Excel, then importing that and putting that in there and then bringing it back to GIS, you could just create a new field in QGIS. Yes. So yeah. And that's probably a shorter way of doing this. So you could change the type to either text or what kind of data that you have. And then once you toggle the thing to type, and then you could just enter in your information and then you're good to go.
So if are there more questions? And otherwise, obviously, there will be a follow-up workshop together with Godwin in the next week. Where
my question actually is to Toby. I'm wondering, so you did all the analysis in what I see in Excel, and then you bring it to GIS for the visualization. I'm just wondering whether this is like an institutional standard operating procedure, or why didn't you do all of that in the QGIS? Or it was just like maybe some convenience. That's what works.
Well, we use MapInfo and we use Esri's ArcGIS platform. So what we actually have is we have a what we call a standard template where it has every river, every road, every bike path, every supermarket, bottle shop, express, petrol station, you name it, all in a single sort of layer that we can then toggle for only show me Coles supermarkets, only show me Woolworths supermarkets. So we have a pretty comprehensive set of tables in our standard template for our desktop GIS platform. I guess I was using Excel in this case for the sake of demonstration, but yes, there is a capacity to do pretty much everything we did in Excel in GIS. But I obviously value Excel for its simplicity and user-friendly nature. But yes, if we had more time, I would love to show everyone how to do this in QGIS.
Okay.
So any other questions from anyone? I think you were quite clear and very well explained workshop, Toby. I can't be thankful enough for conducting this. And we will keep in touch as we move along and progress with this particular workshop and related assessment. So thank you so much for your contribution over the past 2 weeks. I'm sure everyone has benefited immensely, and we look forward to more collaborations with Coles in general, and definitely with yourself in the future in particular. Yeah. So,
my pleasure, and thank you so much for having me. And as I've said, well done to everyone for persevering during this difficult time in studies. And good luck with your property studies, and great choice with property. And hopefully everyone shops at Coles, not Woolworths.
For that, I wish you all the best. Thank you, everyone, for joining, and have a nice evening and a good weekend.
Thanks.
Bye-bye.